Hello, I'm Joel Klein, and this is Developing with Wolfram Enterprise Private Cloud. I'm going to talk about when you should choose Enterprise Private Cloud for an online project and how you would make it work. So we're going to cover, what you can do with an EPC, compare it to some other choices you have, what other Wolfram technologies, including Wolfram Application Server, and how you would make the transition if you have a public cloud application to private cloud. I should mention that I'm going to make the notebook available at the end of the talk, and I did time this. I trimmed things, but I got it to just seconds under 30 minutes. So I will stay and answer questions from the chat once I'm done. I'll try to end a little early to make more room for questions, but it is pretty packed, even though it seemed simple when I wrote it. So this talk is especially for people who want to run a Wolfram application on a network. And you may have a Wolfram application on a network, but it's not working for you. There's some problems with either the scale, you're running into restrictions, or you may really need access to some data source or network resource that's available in your enterprise, but is not available from the public cloud. So what is EPC? Just if you haven't gotten introduced to that, it is like public cloud. You put it on your own hardware, whether you own that or rent it. You connect it to data sources that you like, since it's connecting to the hardware that it's under your control. And you can configure it as you like. You can lift restrictions that public cloud has, tweak parameters to suit your workload. And a big thing is initializing kernels with your own code. And we'll talk about that a little more, but that's a big deal for some people. Some people, it's just public cloud is not an option because you can't do that. And if you don't know what public cloud is, we usually talk about public and private cloud inside the company, just because to keep straight what we're talking about. But this is what many people will just know as Wolfram Cloud. And it's giving you features like the notebook in the browser, basic web hosting with, requests, HTTP requests that can be served with Wolfram language code, and background tasks that are written in Wolfram language. It also gives you your basic file storage, and you can access it from mobile apps from the browser and from Mathematica Wolfram Desktop. So typical things that get built with EPC that we've seen customers do and that we've done ourselves inside Wolfram. Dashboards are a big one, and this is sort of painting with a broad brush, but as a dashboard, I'm talking about just something that's taking in data, processing it, and producing some, I would say, canned visualizations at the end. There is a variation on this, I would say, kind of a data analyst hub, where instead of canned visualization, you have humans responding to requests from clients, whether they're internal or external clients, but somebody's showing up for work, getting access to some data, producing a report that's customized with some visualization. So kind of like a dashboard, but ad hoc, essentially. Online courses are a big one the EPC can be used for, and just another use case for them is really just an API server. I just need to crunch a lot of, do a lot of computation in response to web requests. So an example could be, a classifier. I'm throwing a bunch of images at this EPC, and it's telling me how many oranges are in that tree, how many, nickels are on this tray, or something like that. So I'm going to get a little more specific about an example dashboard EPC use case, just as an example to use to refer to later. So let's say we're running a website. Whatever the website is, we want to know something about our traffic, about how users are navigating it. So the data source for this is just web server access logs. Those are already in place. We know that the information is there. We just need to, we want to use EPC to build out, a way of tracking it. So the web nodes are already routing access logs to a centralized location. So we're saying we're going to install our EPC and we're going to have those logs also routed to the EPC, and they're going to store them in some directory. Then a background task, a scheduled task, is going to wake up, read from those logs, do some processing on it, import them from whatever format it was. Maybe derive some information, maybe do some binning or some deltas, maybe clean some things up, or maybe reject some information, sort of blacklist some information that we know is like test data that we don't want showing up in our dashboard, some things like this. And then at the end, in the visualization part, you have a page that's showing the results of this. So it could be a notebook, or it could be an HTML page that shows images. So this is pretty much dead-on description of something that is already in the Wolfram Cloud that I've helped work on, which is the usage dashboard. And this page that you're seeing down at the bottom is I think there's an embedded frame in here, but there's an HTML page that gets served, and inside that there's a bunch of image links, if you're familiar with HTML. So they're URLs, but they're URLs back to cloud objects, or moral equivalent of cloud objects. In this case, they're hard-coded into the application, but that's a detail. But basically, every single one of these plots, these histograms, these are all API functions that are returning images after they've read some pre-processed data. So some self-diagnosis questions. You might need an EPC if you answer yes to any of these questions. So do you have code or data that takes a long time to load? Are you hitting time or memory constraints in public cloud? Do you have data sources that you'd like to use, but you can't really move them somewhere closer to public cloud? Do you want the functionality of public cloud, but for some reason, like regulatory reasons or just a sort of defense in depth, you really, really need those files co-located with the rest of your infrastructure. You don't want things moving over the internet and so forth. Do you want them co-located? Do you have background tasks, scheduled tasks that you would like them to run more often than hourly? That is a restriction that public cloud has, that things don't run more often than once an hour. And this is a little bit of a subtle one, but it's a good thing to think about, and that is that public cloud, we upgrade public cloud when a new release is available. With EPC, we make the release available, but it's your decision ultimately that, to get the timing right of when you want to upgrade. Maybe you want to download that, put it on a test server, try out your application, and then when you're ready, upgrade your production application to the new version. That one's subtle, but it's there. So I wanted to look at Wolfram Application Server, which Andrew DeLay introduced earlier this week, and compare that to public and private cloud, because there are definite use cases for all of these, and you really just need to examine your own needs and see where you lie. So all three of these are going to support basic serving of websites and writing HTTP responses in Wolfram language. Notebooks are a differentiator. WAS does not have notebooks. It's just not part of its mission. Public and private cloud, this is a core part of its mission. Background tasks, WAS does not currently have, whereas the cloud does. Since WAS is based on Web Mathematica, there is plenty of people using MSP, the Mathematica server pages that are available in Web Mathematica. It does support that. The cloud does not support that. There are definitely ways to get the same functionality in cloud, but if you have legacy MSP pages that you've invested a lot in, WAS is the choice there. They all have file storage. Presently, I'd give the edge to the cloud as far as ease of use of accessing the files, all the different options that they're already available. WAS is pretty new, so it hasn't developed, but you can do it. Permission control, and this goes with users. WAS does not have users, and therefore there's no need for permission controls. This is a conscious decision because WAS's core mission is really high throughput API serving. And the assumption in WAS, very much like Web Mathematica, is that you have a single application that you're deploying. You're under complete control of, or the application is under your complete control, so there's no need to differentiate one user from another. And that does add some overhead, so it's not there in WAS, so that the throughput can be met. Public cloud and EPC does have that. Now there's some use cases where you want users, and so you choose an EPC over WAS. The kernel initialization that I mentioned before. So WAS and EPC have that, public cloud doesn't. And I should just note what I mean by custom kernel initialization. This has to do with at the beginning of a kernel's lifetime, code that gets loaded then. So if your mission is to serve web requests, what you don't want to do on every single request is load 40 megabytes of code. In WAS and EPC, if you've got some giant machine learning classifier, you've got some giant neural network, or you just have a massive amount of code, which some of our customers do, that take seconds to load, it makes more sense to do that up front at the beginning of the kernel lifecycle. And that's just not an option in public cloud, because when those kernels launch in public cloud, we don't know which user is going to get a hold of them. At the time that the request is made, then we can load kernel initialization code that you provide, but that's done on every request. So this is really about the beginning of the kernel's lifetime, not the beginning of the kernel request. Evaluations are restricted in public cloud because it's a shared environment. We need to put a cap on usage, but that's what you get back when you have WAS or EPC is lifting those restrictions. And self-hosting. WAS and EPC are self-hosted. That's the basic idea of those. For public cloud, this is an advantage, right? This is what software as a service is meant to be, is, hey, I didn't have to go buy a computer. I didn't have to do anything to install an operating system or anything. Somebody's done that, and I just need to put stuff on it. That's what I want. So for some people, public cloud, not being self-hosted is actually what they want. It's just the classic, sort of do-it-yourself trade-off. Do I do it myself because I want customization or some other reason, or do I outsource, this service? Accessing the data sources we've talked about. You can access data sources in public cloud over HTTP requests that go outside of the cloud, but then they're going over the internet, and not everybody can do that. So this is sort of a halfway, can't do it and can do it for public cloud, but you clearly can do it for WAS and EPC. I mentioned the upgrade style in public cloud. Upgrades happen automatically. You don't have to do anything. And for some people, that's an advantage. So new version of Mathematica becomes released, public cloud will get that without you having to do anything. With EPC and WAS, you upgrade, at a time that you choose. And just for interest, the basic hosting technology for these different things, WAS is in containers, EPCs are in full virtual machines, public cloud currently is on bare metal. This doesn't matter so much for the most part, but I'll just throw that in there. And finally, there is Wolfram Engine. If you're looking for, I don't want to spend anything, there is a completely bare bones option here to start with Wolfram Engine, put it in some kind of web server, and do that for kind of developing an idea. And then once it looks like you're going to be able to deploy a product, come talk to us about licensing. But that is an option that's pretty interesting. It's very lightweight download, and if you haven't tried it, it's interesting. So let's talk about how to transition from an application that's in public cloud to private cloud, or as you can say, moving out of an apartment into your first cloud home, right? If you think of EPC as buying a home. You do need to plan it. You need to assess your needs and plan it. and then you'll configure it and move your code. And this is sort of the core new stuff that is hard, information that's hard to find, is sort of the core of the talk. So there's 3 big questions you need to think about. You know, your own hardware or a cloud provider, how big or beefy or just what profile of servers do you need? You need to assess, you know, how much RAM and everything the servers are going to have. How many do you need? And then how many kernels of each type do you need? This is what we're going to talk about for a few minutes. But answering all these has to go back to understanding what you're trying to do. What is my application's architecture? And what size and scale do I expect now and in the future? You know, if I'm successful or as time goes by, how does it scale? And how do I need to plan for that? Because you may get away with, you know, 2 kernels today, but if you're successful, then you'll need more, and you want to, you know, have some headroom for that. It's just like, you know, buying a PC. Oh, I need 4 terabytes of storage. Like, oh, okay, well then you get a new digital camera or a video set of video cameras, and all of a sudden you need double that. You know, you got to think about what you're doing, where you're going. So the kernel pools. Cloud has 3 different pools of kernels that at any one time there's a certain number of these kernels in each pool. And then as they're needed, they're taken from the pool, used, either destroyed and then replaced with a fresh kernel, or in some cases they're recycled. So the 3 types are session, deployment, and task. Session are for session notebooks. So if you're in a session and you are, you know, assigning X to a classifier or some data, and then you're adding to it in the next step, you're in a session. There's one kernel per session, because that's how people are used to using it. The deployment kernels, the public kernels, are a little more complicated. These are used in response to HTTP requests and responses mostly. So those would be your API function, form function, cloud evaluate. Every time a request comes in, like, I want to cloud evaluate, we say, get a public kernel, do the evaluation, destroy it, return it to, you know, get a new one from the pool. So the number that you need here really depends on the factors of how often are you expecting API functions. You know, if you're using form functions for a class, are the forms to be used during class time? Are they expected to be used during the evening hours when people are doing homework? You know, it's just a sort of a queuing theory. So, you know, running a restaurant, you know, when's the lunch hour rush and how many do we need at our peak? Kind of a question. They're also used for deployed notebooks. And for deployed notebooks, they're used if you're using dynamics, manipulates. They may also be used for computing some helper data for graphics. And these, you kind of need to play with it a little bit. Just try it out. What's my typical deployed notebook? How much kernel time is it using? To get an idea of how many of those you need. And similar question is for the APIs. And you should be aware that this kernel pool is used for some system stuff, for making the HTML caches of notebooks. And also there's these content-based icons that get rendered. There's some level of that in the background. And, you know, when you're planning an EPC, you can come to us and ask these questions, and we'll help, you know, evaluate what your needs would be. Then finally there's the task pool for services. These are used for scheduled tasks, and basically things that you know, they're not the first 2 categories. They're things that are running in the background. And then, you know, this is usually easier to estimate because they are done on a schedule. So, you know, once an hour I'm doing this processing, or I've got one that's going to run, you know, 3 of them that are going to run to track these, you know, to split load between these different data sources, something like that. If you've got just static cloud files that don't use kernels, they don't use kernels. So that doesn't have to, you know, affect anything. And then as far as number of nodes, you should be aware that there's kind of 2 main ways of running EPC. One is single node, everything fits on a node, and I would say 8 kernels or less is single node scenario. Most modern servers, can do that just fine. As a matter of fact, my laptop or my development desktop can run 2 or 3 EPCs that have 8 kernels just on its own. They're not heavily loaded, but as far as the RAM footprint and everything, they will fit. So anyway, single node versus a cluster, the way that the cluster works is you have one master node that runs all the services. So your database, your web server, your load balancer, as well as the notebook that you configure with, and of course kind of orchestrate configuration from. One node is taken for that, and then you have one or more compute nodes. And you add compute nodes, add or remove compute nodes, as you need to scale. So we have this dashboard EPC example. Let's just go as an exercise through this. So this is the same bullet points I had before. I'm just added highlights for, planning. So we had, what was already in place was the web nodes with logging, and we said that we were going to have the logging get redirected to the EPC as well and store them in a directory. So, okay, we're storing something, we need to plan for the storage. And you might say like, well, after the logs are sort of processed, we don't need them anymore. We're really only going to, use basically a constant amount, a fixed amount. We're not going to accumulate those, So you have to think about that, just what is your data need. Then you have a scheduled task that's going to process those. So you need one task kernel for that. Check. At least one, I guess, is what this means. And then you have your dashboard. And I said before that there's kind of 2 options here. One is just a notebook. Another one is an API function. So between these 2 options, you can see at least one public kernel is going to be needed. But really, it's also going to depend on how many people are accessing this dashboard at a time. So just a little more detail on this. How much data is arriving over time? How much is in these logs that's arriving every hour? And for whatever your processing is, can you process it in an hour, in under an hour or not? If you are taking more than an hour to process it, you're not keeping up, and you need to add compute time or do something to make it so that you can process, you can keep up. Sort of like an I Love Lucy at the chocolate factory when they're getting more chocolates in than they can process. Hilarity ensues. How long is the raw data needed? I kind of alluded to that. Maybe you keep it around as a safety buffer a few days, but hopefully you're not keeping this around a lot. What is your storage footprint? How often is the dashboard accessed, and by how many unique users? Maybe you're in a situation where you just have a few executives and managers that need to look at your dashboard. So, but it's really important that when any one of them wants it, that they can get it, that they're not timing each other out. So if you have 5 people that absolutely have to see this dashboard, then plan for that. There are some other ways to do this dashboard. In this scenario, look up auto refreshed. It's sort of a combination of a scheduled task, but it's a scheduled task that produces something like a notebook, and then the notebook can possibly be viewed by many people at once without really needing any more kernels or something like that. Or delayed has a caching option, so you can produce images with a delayed that cache their data for 10 minutes or something and not use a kernel. So there are a lot of options, and once you get into actually implementing these, some of these things that like, I've never heard of that. Some of these things actually become very important, and they're there because we realize So this was sort of what I alluded to, you know, what is there an emergency situation? Is there a scenario? And I hope if we've learned one thing from 2020, it's to actually plan for emergencies rather than saying, yeah, that's something we should plan for and never actually doing it. But is there a scenario where you really might need a lot of extra capacity or have something on standby to add capacity quickly? And again, Wolfram can help with, you know, this type of planning, give you some options that would work for you. So maybe after all this analysis, we say, you know what, for our current needs, we just need 8 kernels. It's going to fit on one server. Perfect. Now we're ready to actually order it and, you know, get it set up. So here's our envelopes in case you don't have any for doing your calculations on the back of them. I just wanted to walk through how you create the EPC, and I see we're a little bit short on time, so I'll kind of skim this. But basically, you're going to prepare all the nodes in your you know, if it's just one, you're going to prepare one node. You're going to put VMware or something on that node. You're going to install the virtual machine into the hypervisor application, activate the Wolfram products, put your license on there. Set up DNS and SSH keys, get an SSL certificate because it's a web server. Open the configuration notebook and tell it, you know, what it is. It's dashboard.example.com. Tell it about a mail server, select a database password, and then you get to the end, the 3 big red buttons that generate config files, install them on the system, and restart everything, and then you're off to the races, and you've got a cloud. And this whole process, knowing exactly what you're doing, if you already have the node and the VM, I can get an EPC going in something like 10 to 15 minutes. And that's with some fiddling around. If I was in a competition or something, you know, this doesn't have to be a big process to just initialize it. If you're configuring a bunch of things, more than just the minimum, obviously it's going to take a little bit more. Finally, just moving your code to the EPC. Right now, this is not as good as it could be, but it's not terrible. And if you were moving from public to private cloud, you may never have touched $Cloudbase, but you're going to touch it now. So basically, you assign $Cloudbase to the URL, you know, that's www.the.cloudbase domain that you configured for your EPC, and then you just do the regular cloud functions. Most or all the cloud functions also have this cloud-based option, so you can say as a one-off, well, I'm using public cloud. I don't want to change my $Cloudbase, but for this one command, I want to run it on this other cloud. So ultimately, moving code could look like you cloud connect to public cloud, download your files, cloud connect to your EPC, and redeploy them. This isn't as smooth as I would like. It may not be as efficient as I would like, so there is some future work to make this a much better story, basically creating an archive of cloud objects that has all your metadata and, you know, reconstituting it on another cloud, but you can do this. I'm basically at time, so I'm just going to highlight that we've been doing a ton of work on EPC to improve it with automatic clustering. We have extensive documentation now. We've reduced the size of the downloads from about 16 gigabytes to 9 gigabytes by splitting out HTML files. And in 156.1, the pending release, we are upgrading to CentOS 8 from CentOS 6. This is a major upgrade. And we are going to be moving to Docker Kubernetes for EPC, not today, but soon. And basically just improving the experience. I'm going to end there and start looking at chat. Questions. Do we have questions, Dan? So were there questions or there were none? Okay. Does that mean there won't be support for VMs anymore? That is kind of what it means, yes. The move to Docker Kubernetes. I think the idea there is that both public and private cloud would both be using Docker Kubernetes. It would be a unification project, basically. How much does it cost? I am not the sales side of this, so I don't know, and it kind of depends on what you're buying, like how many kernels and things like that. So I would redirect you to them. So I'll stay here another 10 minutes or so until we end or the questions dry up. How do you upgrade an EPC to the new version? Oh, okay, that is something I didn't cover. There is an updater. Let me see if I have something handy that I can show. But basically, once you've already created an EPC, what you're going to get is a tar file when there's a new version released. You install that into the VM and just basically tell it to upgrade things. And that is something that we use extensively. It lets you do things like select individual components to update, which we sometimes do for development reasons, but generally, for end users, you just want to update everything. But what comes in the update tar is if there's a new version of Mathematica with that cloud release, you get the RPM for that. It'll have the cloud application itself. It'll have a component that's just updated packlets. It used to come with the HTML documentation, which is what you get when you're in the web product and you go to documentation, but by default now, that is wired up to reference.wolfram.com. So you use the HTML documentation only in a case where you don't want network connectivity or something like that. And sometimes the updater has some other things. So yeah, Brad is offering his name as a contact for pricing. When do I need to move from a Wolfram Engine running a Docker container on my server to Wolfram Application Server? I mean, if you think Kubernetes will help, that's one answer. Another answer would be that Wolfram Application Server does come with a packlet that lets you manage things from the desktop. It's very similar to the cloud functions in the sense that it's a packlet updatable, in language way of inspecting and pushing and updating, basically managing your installation. So I imagine that's something you've had to provision yourself. If you don't have very many endpoints, you may not need that. Yep, it is Linux based. Right now it is primarily CentOS or only CentOS, but there have been some one-offs that are big projects where we've looked at running on some variations. I would say we haven't done that. It's mainly the VM and a particular version of CentOS. Yeah, I guess I can field questions about Wolfram Application Server too. I haven't worked a lot on that. I do have a small amount of code in that, and I'm involved in the team that's been doing that, and there's some similarities. The WSTP server, I don't have any information. I'm not really prepared to answer questions on that. Can I use a separate Mathematica notebook to deploy updates to the server directly? I assume since you asked about Wolfram Application Server, if you're talking about deploying updates to Wolfram Application Server, Daniel, or did you mean EPC? Because yeah, you can. It doesn't really matter which kernel you deploy things from. It's sort of a remote thing. Windows. That's actually interesting. It's probably a little known thing, but as cloud developers, we actually run the cloud web app on whatever our operating system is. So as long as I've been involved in cloud, for some strange reason, I never thought I would develop on Windows. I actually run the cloud on Windows. And most of the developers run it on Mac. So with some, with some caveats, I wouldn't say that it's crazy to say that cloud could run on Windows or OS X. I mean, most of the things we're writing are, portable in portable languages anyway. So it's not a big deal. The differences boil down to, details about the services that we use. Okay, so we just got a few minutes left. If you've got a question that you're on the fence about, I'm much happier to answer questions of any kind on anything than to sit here and wait. So I guess if you're, yeah, anyway. Any questions from any Wolfram people who may not know as much? Who am I rooting for in the MLB playoffs? Thank you, Bob. You saved me. Yeah, my team is long out. It's very sad. I'm rooting for non-traditional teams, not the big city teams. They're all big cities, but I don't have a clear favorite. Just please, not the Yankees. Anything else? What new 12.3 feature will be best? I don't even know if there's going to be something called 12.3. And I certainly don't have a handle on what all the features are going to be. If I had my druthers for cloud features, they would be some of the things I mentioned, like the backup and restore. And basically, higher performance and monitoring. Those are some things. And actually the dashboard system that I mentioned, we're working on an improvement to that. It's going to be, I think, expanded in the next year or so. But I think the Docker Kubernetes is not just simply repackaging everything in containers. There's also some architecture changes that I think are going to be very interesting. I don't know
Joel, real quick, the meeting's about to end. I just wanted to let you for the attendees.
Yep. All right, so we're basically seconds away now from ending. So I'll try to get the last question in. Will EPC users be required to devote a full kernel to each of those three categories? No, that's a great question. I don't want that. I definitely don't want that to be a restriction. I want EPC users to, not be wasting kernels. That's crazy. So that is definitely something that if it's required now for some technical reason, that we lift that. I should probably stop the share and we'll.
I can end the Zoom meeting for you if you'd like.
Yep, let's go ahead and end then.
All right.
All right, thank you.